Hi, this is Maggie. In an earlier video, we solved a data analytics problem using some Python analytics libraries. In this video, I'm going to solve the same problem with R. This is a straightforward problem that will allow us to practice with R, ggplot2, and some general data analytics concepts. We're going to recreate a chart that's available on ourworldindata.org. There are at least a couple of advantages to recreating somebody else's chart. First, it allows us to check our answer once we've produced the chart. If we don't produce the same chart using the same data, then we have probably made a mistake or misunderstood something. Second, unless we're experienced data scientists or data analysts, it will guide us in following best practices. And third, it gives us the opportunity to explore some data that's already been collected and learn something about the topic we explore. I've chosen this data, which is the environmental impacts of food. I'll include a link in the description to this page. In fact, you might follow along and download the data with me so you can work along with the video. So maybe pause the video, click on the link in the description, and get this page open in your browser. I think this is an interesting topic because I've read stories about the environmental cost of producing different foods, and I think that should impact our food choices when we have a choice. And when I first looked at this data, I learned a new word, eutrophication, which refers to environmental damage caused by nutrients like nitrogen and phosphorus running off the land into a body of water. Okay, so let's take a look at the chart we're going to recreate. This chart is greenhouse gas emissions per kilogram of food. And at first I thought these might be the foods with the highest values, but then I realized there are check boxes off to the left, so you can pick whatever foods you want to see in this chart. If we look at the source of this data, the authors, Michael Clark, Marco Springman, and Mike Rayner, looked at 57,000 food products. I'll link this source in the description of the video as well, although you won't need it to follow along with the programming. So it's a bar chart with foods on the left, kilograms across the bottom, and the bars are labeled and they're all different colors. So to recreate this, we'll need to download the data, load it into a data frame, take a look at it, and then see if we need to do any sort of manipulations to pull out the data we need for this chart. Then we'll need to create the chart. Before we download the data, let's make a project in R for our files. In RStudio, go to File, New Project, and then you can choose New Directory, and then New Project. And then you can use the chooser box to select a directory and a project name. I'll call this Food Impact, and I'll put it on the desktop. This will create a folder for your project files, and you can then share the entire folder with your colleagues, and the paths will work. Just drop your data files in the project folder, and you can refer to them by name only. Or you can drop them into subfolders and just refer to them by the relative path through the folders in the project. So back on ourworldindata.org, click on the Download button and choose Full Data, CSV, to get a comma-separated values file of the data used to produce all of the charts here. We'll drop that into our new project folder called Food Impact. The file is called food-footprints.csv. This CSV has no extra lines. It has a row of headers, the data, and then nothing else, no footer explaining the data, for example. It's ready to be read into a data analytics program. Let's use the reader function read_CSV to read the data in. So I'm going to choose from the File menu, New File, and then R script. And I'll put a quick comment at the top describing the project, and then I'm going to put a comment to read some data in. I'm just going to copy-paste the comment from the Python program I wrote to recreate the chart on the website. It includes a link to the data. Okay, and then I'm going to put a comment, load the reader library. And I'm going to include the code, if not require reader, install.packages reader library reader. I like to use this code in my scripts because it will install the library if it isn't already installed using install.packages, and then it will load the library using library. Now let's use read_CSV to read the data in. I'll call the data frame food, and I'll write food is assigned the value, read_CSV, food-footprints.csv. And let's add a view command, and then save the script. I'll call it food_chart, and then run the script using Control-Shift-Enter. And in the Food tab, we can see there are a lot of columns. For example, emissions per kilogram, emissions per 1,000 kilocalories, emission per 100 grams of protein, etc. If we scroll through them, we find the entity column, which is the name of the food. Suppose we want to extract that vector. Down in the console, I can type food $entity, and I can see 211 values, one for each row or observation in the table. This table does not contain all 57,000 food products that were studied. If I read the information under the tab Sources on the Our World in Data website, it says that they've combined the original products into higher level categories, and these categories use weighted ratios according to how the ingredients are combined to make the food. Now, when we examined this data in Python, we looked for missing values. We can do the same in R using which and is.na. If we apply is.na to our data frame food, like this, is.na food, R returns a data frame the same shape as our data frame, or more properly, tibble, with the values replaced by true if there was an na value in that cell, and false otherwise. That is not very helpful, though. We'd have to scan through the entire structure to find the values. If we use which with is.na, we will learn the indices of the na values. Here's the documentation for which. We will want to set r.ind to true so that we can see where in the data frame the na values are. So we'll type which is.na food for the logical array or data frame or tibble. And we've already seen what that looks like. And then r.ind equals true, so that we'll get the row column indices of the true values in the is.na food data frame. And we can see that 2 rows contain na values, row 137 and row 194, and 6 columns, 3, 7, 11, 15, 19, and 25. Let's use these values to index into food. I'll want to include the entity column as well, so I can see what foods they are. The entity column is column 21. I counted to find that, and I'm going to put it first before the 3, so I can immediately see what foods these are. And we can see they're olive oil and sunflower oil, as we also discovered when we looked at this data with Python, and it's the protein columns for which they have na values. As discussed in the Python video, if you're working with data that's more raw than this, you'll want to spend a lot of time understanding what you have. You'll want to know the full range of values for each column, whether they were read in as the proper type, or maybe something in the original file caused them to read in as text or character data, and where there's missing data. There are ways to deal with each of these situations, but they vary depending on what you have, how it was collected, and what you're trying to do. We're going to move on to creating our visualization. So I think it would be very interesting to order these values and create a chart showing the highest and lowest, for example. But it makes sense for an interactive visualization, like this one, to allow people to choose the foods they eat regularly. So let's make a data frame that is just the name of the food and the greenhouse gas emissions per kilogram. Those are columns, and just the rows listed here: beef burger, macaroni cheese, meat pizza, eggs, rice, cow's milk, vegetable lasagna, coconut milk, lentils, dairy-free ice cream, tomatoes, vegan pizza, avocados, bread, bananas, almond milk, almonds, potatoes. And I do want to point out, we're only looking at one dimension of environmental impact here. So if you're interested in the environmental impact of foods that you like, I'd suggest reading the article and looking at all of the tables. So how do we create a data frame with just those rows and columns? Remember that we can select from our data frame using logical expressions, and here, to select the rows, I want to use in, which will return true if a value is within a vector, and false otherwise. I can use the resulting vector of Boolean values to select rows from my data frame. So let's put this solution in the script. I'll write a comment that I'm going to select just some foods and the entity and emissions per kilogram columns. I'm going to create a vector of the foods we're interested in called entities, since they're elements from the entity column. Okay, and now I'll assign to a new data frame. I'll call it foodsviz, because we're going to use it for our visualization. Foodsviz is assigned the value of food, sub, food entity in, that's percent in percent, entities, C, open paren, and then I'll list our columns of interest. We already know the entity column is 21, and the emissions per kilogram column is 1. And let's add a view foodsviz and run that. And our foodsviz table comes up, and that is 18 observations or rows of 2 variables. Now, in order to produce a bar chart with the foods showing in order from highest to lowest, we'll need to make the entity column a factor, sorted by the emissions per kilogram column. I'm going to do this in 2 steps, although there are other ways to do it. Remember that we have a few functions that we can use to order a vector, such as order and sort. But if we want to use a vector to order the data frame, then we'll want to have the ordered indices. So, for example, if I write sort foodsviz emissions per kilogram, and since that column name has spaces in it, I enclose that in single quotes if I'm using the $ operator. Then I get a vector result, which is the ordered values. But if I use order instead of sort, I get the indices of those rows in order. For example, 14 is the lowest at 0.272762, and if I look up in our data frame, we can see that is the value in row 14, potatoes. So we'll use that vector of indices to sort our data frame. So I'll write foodsviz sorted is assigned the value of foodsviz sub order foodsviz $ emissions per kilogram, comma, in my script. And I'll put a comment over it, sort by emissions. And we can view that as well. And if we run the script, now we have the sorted table. Now that we have that entity vector in the order we want it, we'll make it a factor with its current order as the levels. So I'll write foodsviz sorted $ entity is assigned the value of factor, that's the function that will create a factor variable, and then I'll pass in the data, which is foodsviz sorted $ entity, and then I'll write levels equals foodsviz sorted $ entity. It seems redundant, but where previously this was character data and would be sorted alphabetically in our chart if we converted it to a factor without specifying the levels, now it's a factor and the levels are set by our sorting by the emissions per kilogram column. We're now ready to create our bar chart. Let's load ggplot2 in using the same code that we used to load in Reader. I'll put a comment, load the ggplot2 library, and then, if not required, ggplot2 install.packages ggplot2 library ggplot2. In ggplot, We create the plot object with the data, and then we add components specifying the geometry, or type of plot, and aesthetics, how the plot will look. We'll write ggplot foods viz sorted, AES, and here we'll specify our X and Y. AES is short for aesthetic mapping, and this tells ggplot what parts of the data to map to what parts of the plot. We're going to specify X equals entity, and Y equals emissions per kilogram. And that punctuation is the backtick, not single quotes. If we use single quotes, R will consider our name to be a literal string, but if we use backticks, it will look in the data for a column or variable of that name. The backtick is next to the 1 at the top of the keyboard. So we'll close that out, and then we're going to add our geometry, which is geom bar. Now, geom bar usually wants only one column. So if we want to have our entity column be basically the labels for our emissions column, we write stat equals identity as an argument to geom bar. Then we add coord flip so that our chart will be horizontal rather than vertical, and select and run this new part of our script with Control Enter. And we get our chart. And that's a great start. Now, there are a lot of things we might do to make it look better. This is a ggplot2 cheat sheet, and I'll include a link in the description of the video, along with a link to a free open source textbook with an introductory chapter on ggplot2. On the second page, we have color, themes, labels, and legends. I'm going to start by looking at geom label in help. And it says that geom label draws a rectangle behind text, but that's not what our plot that we're imitating looks like. It says to use geom text if we don't want the rectangle. So I'm going to add the data that I want to use as a label in the aesthetics argument to the original ggplot command. Label equals emissions per kilogram. And then add geom text at the end. And that looks okay, except the text overlaps with the bar. So again, looking at the help file, there are nudge x and nudge y parameters. We want to set a nudge y, and that is, I believe, because we have flipped the coordinate system. We'll try to set that to 10. And that's a little too far. Let's try 8. That looks okay. Okay, now I'm going to skip over some other things, like adding a title, and do something that I didn't do in the Python video. Notice that in the chart we're duplicating, the values next to the bars are rounded, and they have units, kg. How can we produce labels that look like that? Let's add a column to our data frame for the labels, and pass that in as the label parameter to AES. So above the ggplot code, I'm going to add a column to foods viz sorted called bar labels. So foods viz sorted, $bar labels, assign the value of, and now we're going to work from the inside out. So we're going to round the emissions column to reduce the number of values to the right of the decimal. So round foods viz sorted, $emissions per kilogram, comma 2 to round to 2 decimal places. Now we want to convert that to a string or to character data and append kg to that. So before round, we'll write paste open paren, and then after comma kg close paren. That will recycle the kg, in other words, repeat it as many times as needed to append it as a vector to the vector of rounded emissions values. Paste will also convert those values to character data so we don't have to. I'm going to use that new column as the argument for label in AES in our ggplot command. So let's try running that. And that looks much neater, and I think I can move the labels closer. Let's try nudge y equals 4. Yes, even better. I hope that was an interesting problem to see in R, and if you like, you can compare the R version to the Python pandas version. There's a link in the description. As I mentioned before, I like working from published data and charts for practice because we know how it should come out, and it helps us explore the tools we have available. You can grab this code in my GitHub repo if you want to play with it further. Have fun with it.